let's start with thermodynamics. So, first of all, what thermodynamics mean? In this case, we have two words here, that is thermo and another is dynamics. So, thermo basically means which is related to heat energy, and dynamics means that changes. So, what thermodynamics means is actually the study of transformation of heat energy into other forms of energy. And that's what it means. Literal meaning is actually heat energy, how heat energy gets transformed into other forms of energy. So this is all we need to learn in the thermodynamics. So it is actually the transformation of heat energy into other form of energy. It could be any other energy. Now, we need to know some important terms related to thermodynamics. So, the first term is thermodynamical system. Like, what does it basically mean? So, it is actually a assembly of extremely large number of particles. It could be atoms, it could be molecules. So, if I consider this as my thermodynamical system, then we have in it a large number of particles in it. That means it could be atoms, it could be molecules, it could be particles. So this is my thermodynamical system. Now whatever be its surrounding, like outside the walls, whatever be the surroundings, it will be termed as surroundings in this thermodynamical system. So thermodynamical system is assembly of large number of particles. Now, one more thing you should know is that it could be solid, it could be liquid, it could be gases, or it could be in the combination of two or more states. Like sometimes we can take solid plus liquid, we can take liquid plus gas, we can take gas plus solid. So these three can exist as well, and many more can exist as well. So it could be in solid, liquid, and gas. It could be in the combination like solid, liquid, liquid, gas, gas, solid. So it could be anything. So you must remember what thermodynamical system is. So it is assembly of extremely large number of particles. It could be in the form of solid, liquid, and gas, and it could be combination as well. Now, whatever the second topic, that is surroundings, I have already discussed. So anything outside the thermodynamical system is known as surrounding, which can have a direct effect on the system. The surroundings may affect this thermodynamical system. Now, we need to know how boundary walls of gaseous system are. So they are of two types. The first one is diathermic walls and another one is adiabatic walls. So in the case of diathermic walls, heat can be transmitted. In the case of diathermic, heat can be transmitted, and in the case of adiabatic, it is opposite. That is, no heat can be transmitted here. Now we need to know about thermodynamical states. So the thermodynamic states can be described by the properties of system such as composition, like what they are made up of. So the first is composition, the another is temperature, the another is volume, the another is pressure. So these are some thermodynamic state, not system, sorry. So properties of system can be described by are the composition, temperature, volume, pressure. Now we have another thermodynamic parameters based on state of matter. So let us know about thermodynamic parameters. So in the first case is under solid. In the case of solid, we have some parameters like area, we consider volume, we consider temperature in case of solid system. Now the second is liquid system. So whenever we talk about liquid system, we have density, we have temperature. These are the parameters we are talking about. Density, temperature, and we can also consider surface tension. Now, last but not the least, it is gases. So in the gaseous system, we take into account is temperature. We need to know pressure. We need to know volume. And the last one is heat content. What content we have inside the system. That is denoted by Q, volume is denoted by V, pressure is denoted by P, and temperature is denoted by T. So we should know what all parameters we have under different system. We need to know about solid, we need to know about liquid, we need to know about liquid and gases. Now the next is equation of state, which is very important from viewpoint of numericals. So equation of state. Equation of state for ideal gas. As we know, we have ideal gas. We consider actually ideal gas in this case. So it will be PV equal nRT. Now P is pressure, V is volume, T is temperature. R in this case is universal gas constant. And N is the number of mole of an ideal gas. Now we have thermodynamic processes. So what thermodynamic processes are is where we have some changes in the state of thermodynamic state, that is thermodynamic parameters of the system change with time. It is always with time. So thermodynamic processes are of four types. That is, first is isothermal. We need to talk about two mainly, that is isothermal and adiabatic, but I would be talking about four of all. So that is isothermal, adiabatic, isobaric, isochoric. So isothermal is that which occurs at a constant temperature. In this case, the temperature should be same throughout the mechanism. Now, the second one is adiabatic. Adiabatic is when, as we have already discussed about adiabatic, it says no heat enters in it. So adiabatic is that in which no heat enters or leaves. Now the third one is isobaric. Isobaric is that which occurs at constant pressure. Now the fourth one is isochoric. So isochoric is that which occurs at constant volume. So isothermal, constant temperature, the temperature remains same. In the adiabatic, no heat enters or leaves. Third, isobaric, that is constant pressure. Isochoric is constant volume. So I would be continuing with the next lecture with isothermal operation, talking more about isothermal operation. and adiabatic operation. Thank you for listening. Have a great day.